My name is Dobromir Montauk. I apologize, but I'm going to speak in English. I apologize a second time because I tend to speak too fast. If I'm speaking too fast, just wave your hands or jump up and down and let me know so I can try and slow down a little bit. So my presentation today is going to be about a bit of a personal story here, moving from a monolith to microservices. One of the technologies we touched upon was Mesos, Aurora. I'm going to mention them, but I decided for you guys to do something a little bit broader and focus a little bit more on the ideas, not just the technology. I didn't want to do a laundry list of we use X, Y, and Z, and you should too, because that's kind of boring, right? And you guys may want to use different things than we used. So I want to talk about the ideas we used, because I think those will apply to everybody. So personal story here. I went to Telepart after 9 years of Google. And Telepart was sort of a standard startup, right? We had the monolith. In our case, it was a large Python app that did basically everything. We keep throwing things on it, and it worked. It got you where you had to go. It was generally a little bit slow, perhaps, right? It wasn't exactly the fastest thing. We were running on 1,000 machines because it used so much RAM and so much CPU to do what it needed to do. But it gets you there. And as your organization grows, you kind of realize you need to change, right? This is not going to work scaling up beyond about 50 engineers. We were at 50 when I went to Telepart. And so you go, well, what's the right way of doing things? And you hear microservices, right? It's in the air. Everybody's talking about microservices. I'm like, all right, well, let's try that. And you kind of have an idea in your head, like, what is a microservice going to look like? Well, it's probably going to look like something like this, right? Like, all right, I have all these one little service that's just moving super fast, and all together we're just like moving super fast, and life is going to be good, right? It's going to fix all our problems, right? I already see some people shaking their heads. It solved all my problems. It didn't solve all your problems. Exactly, right? So, yeah, you go ahead in microservice world, and a few years later, you've got your little Java app there talking to MySQL, and you've got a Go app that maybe is using Kafka PubSub, and then you've got somebody decide to throw Node.js that maybe is talking to Cassandra, right? And this is your little sort of microservice world. And instead of ending up in this, you end up more something like this, which is my morning commute to Twitter now. Thousands of engineers. Everybody's moving, but they're not moving as fast as they expected. Right? They're moving much, much slower. And in particular, it's very difficult for any one person to move quickly. Right? Sort of everybody's moving at a steady pace. So I'd say overall, like, what did you actually get when you moved to microservices? And I think the real question is actually, what is the problem we're trying to solve with moving to microservices? Like, why do companies do this, right? And at Google, of course, when I joined, they were already way, way in the microservice world. Twitter has been in the microservice world for a couple of years. Telepart is now in the microservice world as of about 6 months ago as we did the transition. So question for you guys, what does it mean to move fast as an organization? I do expect an answer here. This is not rhetorical. When somebody says we need to move fast as an organization, what do you understand that to mean? Adapt? Okay. But what does it mean to move fast as an organization? Who's moving fast? What is fast?
Add something or change something in our system infrastructure. Okay, it's adaptability, I think. Be able to find a new
Yeah, but
solution.
you're an engineer. You're supposed to write code. If I come to you and I say, you need to move fast as an organization, what do you hear?
It's to be able to implement and deploy and new things or change things the simplest way.
Right. As an engineer, you're like, oh, if I need to move fast, I need to be able to get something done, write some code, get it out in production quickly. Right?
Yeah.
Okay. So when an engineering or a manager thinks of moving fast as an organization, what do they actually think of? Any ideas? They think sort of more about throughput, right? When you've got thousands of engineers, I don't really care if you can get something launched in a day or two. What I care is that all of my engineers are sort of moving at a speed that adding another engineer actually adds to the organization, right? As in the whole organization now moves faster, okay? So the real concept here is latency. Does a single request, does a single feature get done really, really quickly versus throughput? Does the whole organization as a whole get a lot of stuff done, even though perhaps a single request ends up being very slow? right? And I would argue that most large organizations are actually optimizing for throughput, not for latency, right? Why? Well, because you want to be able to scale your business. The way to scale your business is you hire more engineers. Well, if you hire more engineers, they better be adding to the business. So at the end of the day, you don't really care if one engineer is moving quickly. You care only if the entire organization is moving quickly, which is a different definition than most engineers have, because engineers themselves think, well, I'm moving really slow. This sucks. My job sucks. I'm going so slowly, right? But they don't see the fact that the engineering organization as a whole might be moving faster. So there's sort of a disconnect here, because I think a lot of engineers want to move quickly. They go into microservices thinking that they're going to be moving quicker, but that's not really the point, right? So does it have to be this way? Can we do better? Can we get both? So why is feature latency actually increased when you move into microservices, right? The answer here is, well, working across the stack is hard. When you have one monolith, one big system, well, everybody knows how to bring it up. Everybody knows how to deploy it. Everybody knows how to, find the part of the code that needs to be edited. It's just, there's not that much code to look at to begin with, but even though there is a lot of code, there's sort of all the tooling around it's pretty standardized, right? But when you end up in a microservice world, then suddenly, more likely than not, you end up having lots of teams that own different parts of the code. They do things differently, right? They don't do things the way you do them. So what's your option? Well, this is the standard option. You go to a meeting, and you talk to somebody, and you try and convince them to put it on their next week's goals, or perhaps next month's goals, or perhaps next quarter's goals. And then, by the way, this is a perfectly rational and good way of doing things for very large projects that last a very long time, right? You want to get everybody aligned, and you want to get every throughput going quickly. Okay, but what about the risky stuff? Right? What about like that 2-person experiment that you want to just try out in maybe a week or two and get it out and get some numbers and see if it works or not, right? That doesn't really work with this approach, right? Because you're just going to blow your 2-week budget on going and trying to convince other teams to do things for you. So what do you need? Well, I'd like to say that the solution to your problem is something like this, right? You want to hire engineers who are as badass as James Bond, right? Like James Bond is amazing. You can drop him in any country on Earth, right, with nothing. Basically, give him a tux, he'll probably be fine, right? It doesn't matter what the language is. It doesn't matter if he doesn't have a currency. It doesn't matter if he doesn't understand the culture. He's going to get the job done, right? He'll just figure it out and get it done. So you really want to hire a bunch of engineers like that, right? Well, I've met engineers who you basically give an editor and somehow magically the project will happen. Doesn't matter whose code they have to edit, it happens. But I've met a lot more engineers who are like this, right? This is actually me as an engineer, right? Like just a few weeks ago, I was like, oh, I'm supposed to do something on the Twitter stack for the first time. All right, well, shit, it's in Scala. I've never done Scala before. It's in Pants, which is Twitter's internal build system, which has its own weirdnesses, right? It's based off of Blaze, which is a Google thing, but not nearly as good. They use some packaging format I've never heard of, right? I was totally lost. It took me 2 days to write like a simple regular expression parsing thing so I could match some URL and get it deployed in production. 2 days, right? That is not James Bond speed, right? That's this guy's speed. What's worse is not only are most engineers actually about this effective in somebody else's code base, the people who own that code base, they look at you and they go, really? You're going to come and change things in my code base? This is how they look at you, right? They go like, oh my God, here comes some guy who thinks he knows everything. He's going to make some changes. He doesn't know how anything works here, right? I don't want him touching my code. And the problem is I've seen actually teams discouraging what I call engineering tourism, right? They say, no, just tell us what you need. We'll do it for you, right? Don't touch our stuff. We'll do it for you. That's the wrong approach, right? That's wrong-headed. Engineering tourism is actually the only way I've seen low latency changes happen across a stack, right? Where 1 or 2 engineers will go and change things across a bunch of different microservices to launch their feature over a very short period of time. So then the real question isn't how do we avoid this guy coming around and changing our code? It's instead, how do we make engineering tourism actually a goal and make our infrastructure support engineering tourism? What are the technical solutions we need to have engineering tourism as a thing? Like, what do the tourists actually need? All right? So here's like big idea number 1. We need to support tourism in our code base. How do we do that? And hopefully as you guys are building all your systems, you always keep in the back of your head, as I'm building this, will tourists be able to show up and do a good job? The question is, what do tourists need? So predictability. This is most important, right? Whenever a system is predictable, tourists can pretend to basically be a local, right? He knows how it works. He's not really a tourist. So how do you make things predictable? There's two ways. One of them, it's consistent. It's just identical to a system he's seen before. That's the best. And number two is if it's not identical, it's logical. He can basically figure it out. He's like, well, if I was doing it, I would do it ABC. And I will show you some examples of his stuff later. We're going to go into a lot more details on actual technologies. But one example for us of consistency is every single server that we release, every single server always has an HTTP endpoint. Always. Why? You'll see in a moment why that's important. Because you need discoverability. If things are not predictable, then they need to be discoverable. Right? You're a tourist, you show up in somebody's system, you're like, I don't know how this works. Well, hopefully you can click around and find out. Right? That's why every one of ours is a HTTP endpoint, has UIs. I'll explain that in a moment, a little bit later. Right? So discoverability is able to learn how a system works without asking anybody. UIs, by the way, are the best tool here. Engineers hate building UIs, but we usually recommend it. We're like, if you're building a complex new service, make sure there's a UI specifically for your service. What else? Ownership. This is one of the big challenges in microservices. Who owns this system? Who do I even get approval for putting code in? Right? Do you guys have an ownership system? Do you have a way of knowing just random part of a code base who owns it? Owner files are a good way of doing that. I'll show some other examples of how we do this. Friendliness. This is a culture thing, right? You really want to encourage people to come in, right? That means good documentation. That means office hours. Means anything it takes for people to feel comfortable and to want to help you, right? And want to make changes in your system. And finally, of course, Bond would not be Bond if he didn't have amazing gadgets, right? This is the guy who actually makes Bond. Q. I mean, otherwise he'd probably look more like the tourist guy that we saw earlier, right? So if you don't have a team that's helping these engineers, these tourist engineers, actually jump from system to system and have amazing tools that'll explain how the system works, how to make changes to it, it's going to be hard for you to have people behaving like James Bond. I call this like a Q organization. We call it engineering effectiveness at Twitter. You need somebody like Q for the second reason. So big idea number one we had was engineering tourism. You're going to want that. Big idea number two, this is the other problem with microservices. This is going back to our throughput problem, right? Engineers or organizations move to microservices in order to increase throughput of organization. But they're now paying N times M overhead. So what do I mean by N times M? Well, when you have the monolith, you have to have a deploy system, right? Obviously. You have to monitor it, obviously. You have the logs, obviously. But that's fine. You build one, then you build the next one, and over time, kind of all that stuff happens. It never really feels like O of N. It kind of feels like O of 1 and O of 1 and O of 1 again. So you're okay. But now you want to bring up a new microservice. So what do you have to do for your new microservice? Well, at Google, this was about like 8 years ago, I tried to bring up a new system. It took us 3 months. Why? Because we had to go through security reviews and production reviews said that we had to have, stack trace system, we had to have latency metrics, we had to make sure we were alerting, packaging, blah, 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 right? This is just like a tiny little word cloud of sort of all the different things you have to do for your microservice. So now your company, your organization is paying O of N, the number of things you need to do, times M, the number of microservices you have, right? So your actual throughput is decreased compared to what it could be ideally. So how do you solve this? This overhead, by the way, can be quite large. Is this a problem that you guys feel like you have? Like when you bring up a new microservice, like you go, oh yeah, I spent a bunch of time doing this. Is this a common problem here too? Do any see any nodding your heads? Is it at Telepart and at Twitter, this was a big problem. So what do you do to solve this? You want to make the marginal cost free, right? When you bring something up, you get all this stuff for free. It just happens. It's there. It's magical, right? How are we going to do that? We'll have to look at the tooling in a second. We'll go into some details here. So this probably means automation, standardization, right? Make sure that whenever you deploy anything new, you don't have to think about all these different problems. They're sort of solved magically for you. And that gets you back to the O of N instead of O of N times M. All right, so we have these two big ideas. Right, number one, build for tourists. And number two, marginal cost, you want to take it to zero. So we're going to go into details now. So this is the a list of all the technologies and some stories about them and things like that. But before I do that, I'd like to see if there's any questions about this, any thoughts about this. Because the next part's going to be interactive. So I want to make sure everybody understands this. Questions? Am I speaking too fast? Well, then I expect questions. I'm not going to move forward until somebody asks a question. Come on. I'm going to start asking you questions if you don't ask me questions. Engineering tourism. How much do you guys do at Allegro? Why not?
Not much because it's too hard. But we are going in there. With all the stack, with all the app engine, with continuous delivery, I think we are going there to decrease this marginal cost rapidly, I hope, next months. Yeah.
All right, so engineering tourism, not really a thing yet. Has anybody here tried to do some engineering tourism? Has any good stories about it? All right, I want to hear a story here. Just what was bad about it? What was hard? Red, right here. Closer. Oh, there's one back there too. Perfect.
Okay, so we last week we introduced some feature that required us to introduce changes in code base of 2 other teams, and I didn't find it difficult. It was really nice, and the code base was easy to understand. And we worked together. They helped us. So I think it's a thing in Allegro. It's not like we don't do it.
How did you find out what their deploy system was like?
Because it was exactly like ours.
How did that end up happening? How did they end up having the same thing you had?
Because of standards.
Excellent. Other story here?
Well, my story was a bit more negative because I'm a sysadmin by heart, and I did more of a sysadmin stuff before, and most of our stack is written in Java, while I do Python. And switching to another language just to do a minor feature took me way too long, because I just added a dependency and everything just broke, and I didn't have any idea who to ask to get some help for that.
Why weren't you sure whom to ask? Was like the ownership unclear of the system, or communication channels unclear?
The ownership was rather clear, but it was just a feature that I was doing because I wanted to have it in that system, but you had to schedule somebody take someone's time for it, and I just didn't want to take that much for him.
Okay, because that sounds like a friendliness issue a little bit. Like you didn't feel like that team was really going to support you or help you out with your thing. You didn't want to bother them. Okay, cool. Any questions for me before we continue?
Yes, I have one. What in Twitter organization supports engineering tourism, and what discourage people to do it?
Yeah, good question. So what supports engineering tourism and what discourages it? So I'll go through a bunch of the tool sets that we use. So the backstory here is, as part of Telepart, when we were starting to investigate microservices, we ended up with basically using the entire Twitter stack. So we became quite familiar with it before Twitter even was talking to us about buying Telepart. Now that we're inside of Twitter, of course, the whole stack is the same. So what Twitter does, I think, fairly well is that they have a very large engineering effectiveness organization, which basically makes sure the standards across things like deploys and testing and monitoring and so on, right? And so the bigger that organization gets and the more tools they can build, so they move up the stack. And they start solving more and more different problems for you. So you start getting magical infrastructure that just works. So they kind of started. They've just recently started doing that. I think what they do poorly is probably the culture part of it. And I think this is probably more common. Google was the same way. The tooling was amazing, right, at Google. Like, it's still something I hope to use again someday, is just the power of the tools you have available to you. But the culture is the hard part. How do you actually get other teams to want to have you come in and change things? Right? That didn't really exist at most teams at Google. Does not really exist at most teams at Twitter. I think that's a people problem, and it's much harder to solve than the tooling problem.
how wide the engineering tourism is in Twitter. For example, is it only limited to developers or engineers from microservices, or are mobile people also tourists, for example, going to some microservice team to implement some feature?
I have not seen that much tourism. So I would say the answer is probably not very wide. Probably within a certain stack. So example, maybe 1 or 2 layers down, you run the ads front end, you want to make a change to the direct service below you, maybe to the back end schemas, you can do that. People are not really jumping across organizations, right? And you end up having, again, like I said, the cultural problem where if you want to make a change, you end up going to tons of meetings and you're sort of discouraged from just making the change rather than being able to just send CLs. But it sort of depends on the team. I work currently in the revenue side of it, and the revenue side I think is fairly protective. Perhaps it makes sense for them to be protective. But yeah, culturally, they're not super open to people coming and making changes to their stack. Cool. So let's jump into some of the details here. And feel free to interrupt and ask questions. I prefer to make questions live whenever possible. So I said the next part is going to be kind of interactive. So we have a bunch of concepts, right? We have 2 big ideas: tourism, marginal cost to 0. Under tourism, we have consistency, predictability, right? These kinds of things. As I talk about some of the technologies we used and sort of why and what they've solved for us, please shout out, like if you think, oh, that's predictability, or that's marginal cost to 0, just shout it out, right? And I want to see what people feel, why we use these things, and what are sort of the solution, what big ideas do they fall under. All right, so first one, Mesos Aurora. This is the sort of the fundamental basic building block of our system. Right? We're on AWS. We didn't really need to go to Mesos. Who here knows what Mesos even is? Raise your hands. Just want to get a rough read. Pretty good. All right, so for people who aren't familiar, quickly, 1-sentence version. You have a bunch of machines. You really don't want your engineers worrying about disk space on machine 35 running out and therefore their system crashing. Right? You want to abstract that away. Think about resources, not machines, ideally. So Mesos will do that for you. It'll move jobs around where the resources are available. Machines go away. Transparently is basically handled for you. Aurora is another layer on top of Mesos, much less well known. Who here has actually heard of Aurora? Raise your hands. Yeah, much less. Aurora and Mesos actually go hand in hand at Twitter. There is no Mesos without Aurora. Unfortunately, in the open source world, this hasn't quite happened yet. People are using Mesos, and there's a bunch of different schedulers. Aurora is sort of the UI on top of Mesos. It's the actual deploy tool. It's how engineers actually get their code. It's what they actually use day to day. It's how they say, I have this piece of code, put it out there. I need this many machines, this many resources, right? If things go bad, roll back, sort of all that kind of authentication, authorization stuff. So example, here's a screenshot. So this is the fundamental part of our system. Why? Well, everything needs to be in production. Everything needs to be deployed. The very first thing we rolled out when we were trying to move to microservices was this, right? So what problems does this solve? Without even me explaining what you see here, quickly, what do people think? What categories does this fall under? So of the ideas we described before, right? Louder? Sorry, hard to hear you.
It's influence throughput and its cost of deployment as well.
Okay, so cost of deployment goes down. Why does cost of deployment go down?
Because you don't need to think about machines. You just put it, have consistent interface to all your resources. So it's much easier to deploy.
And the other big thing is it's just consistent tooling, right? So every new microservice we built had to build its own deploy system when we started, right? So we started doing these microservices. Every person would build their own deploy system. We had some standardization, technically, fab files, Python, right? But of course, it was a mess. We moved to this, and suddenly nobody has to ever think about deploying ever again, right?
Did you evaluate Marathon?
Yeah, we did evaluate Marathon. I can tell you off the record exactly what I think about Marathon. On the record, Marathon does not have nearly the number of features that Aurora has. It also has not been tested at scale. My general rule of thumb is don't use anything that hasn't been tested at least 100x bigger than you have. We are running on thousands of machines. We have to be able to have something that would guarantee to work on tens of thousands of machines, and Marathon has not. Right. I've heard since then, having talked to a lot of people about who in the Aurora community who've tried Marathon, they've all given it up because it doesn't scale. It's been a big problem. Also, Marathon is basically a way for Mesosphere to sell Mesos by building a very fancy schmancy UI that CTOs, enjoy because it has lots of pretty graphs on it. This is ugly and it's functional, which is exactly what I needed.
How do you manage resources underneath of Mesos?
How do we manage resources underneath of Mesos? This is complicated. AWS is a very hard world. Who here has ever worked in AWS? Not that many people, right? So Mesos' target audience is you've got a data center. You've got all these machines. They're kind of up all the time, right? So all you really need is just a system on top of them, which will move things around. AWS becomes more complicated. Your machines can disappear at any time. And you can pay for them in lots of different ways. So I think we pay for our machines in at least 3 to 4 different ways. We have reservations, right, which is sort of cheap because you tell AWS ahead of time, I'm going to buy this machine for 3 years. Here's how much I'm paying. We've got unreserved machines. This is, hey, bring up a machine, but keep it up. Like, please don't make it go away. But you're not going to keep it for 3 years, so a lot more expensive. And then you've got spot instances. The best thing about spot instances is they're cheap. They're so cheap. You can get, I don't remember what it is. I think it's 50 cents for 32 CPUs and 60 gigs of RAM. 50 cents per hour. Super cheap, right? But spot instances can go away the moment that somebody else comes around and says, I'm paying more, right? It's just a marketplace. So your Mesos cluster becomes complicated because you have different cost structures. What machine types do you throw in there, right? I forgot to even talk about machine types. More disk, more RAM, more CPU. What do you want to do, right? So we started simple. Our Mesos cluster is basically just reserved instances, a fixed number of them. Now we've started doing auto-scaling, and I'll talk a little about auto-scaling in a second. So you guys, for your data center, you've paid for it. You're out of luck, right? That's how much it costs. You're stuck. In AWS, I don't want a machine. Make it go away. Stop paying for it. Right? Well, guess what? In the middle of the night, what our traffic looks like. It's pretty low. There's no point in paying for all those machines in the middle of the night, right? So we started with Aurora and Mesos on just a fixed cluster size. And just in the last couple of weeks, we've rolled out auto-scaling, right? So we actually now reduce the number of tasks we have. So here you can see an example. I forgot to describe what this is, so I'll talk about that real quick. Here you'll see every one of our jobs now becomes a logical namespace. What is a logical namespace? Well, you have a role. In this case, it's the bidder. The bidder is where we make all of our money. It's actually what's bidding on internet traffic and figuring out who to show ads to, right? Well, then we have an environment, production. This is prod, right? Then we've got the job name. In this case, FB bid. Anybody want to guess what FB stands for? Yeah. So we have 60 instances of the bidder, which are just bidding on Facebook traffic, right? Well, in the middle of the night, you don't need 60, right? You could probably get away with just 5. Right? There's really nothing happening in the middle of the night. And so right now we're paying for all these instances, which are doing nothing. With auto-scaling, we just start removing these instances, the logical instances. And once the logical instances free up, then the actual resources on the cluster free up. We can start shutting down machines and save money on that. So how do you actually do the shutting down of machines? Well, you need to have a scheduler, which is smart. You need tight bin packing. Right? You want to make sure that your scheduler is looking around all the machines. It doesn't actually put something on a free machine which is completely empty. You want it to put it on the machine that is almost completely full. So our friends at Netflix actually just open source something that we're trying out called Fenzo, which does tight bin packing. It also has nice hooks into it, which lets you shut down machines. You guys might be saying, we don't care. We're not on AWS, although I think you guys are actually trying out AWS, right? Or we've got our fixed data center. We don't care. Well, look at the power cost of your fixed data center. Maybe shutting down machines would actually save you money. Right? Maybe tight bin packing actually makes sense. So then this kind of technology will give you all that. So what does this get us? It was predictability, right? Everybody deploys the same. I didn't hear anybody say discoverability. Right? One of the nicest things about this UI is you can just click around. And I was going to demo it, but I can't get on VPN right now. Right? But you can literally click around and discover what's running in your cluster. Who's running it in your cluster? Who's the owner? How often do they push? When's the last time they pushed? Right? Oh, I can go click on their logs and see exactly what they're doing. Right? So with a UI, a very simple UI, you can actually learn so much about how your environment is running that you don't need to go talk to anybody. You can go figure out where things need to happen. Right? It's one of the big wins for here. So this is the base of our cluster, Mesos and Aurora, and we sort of started building everything else on top of that. Anything else I want to say here? That's it. Next. Sorry, clicker not working. All right, next is Finagle. This is basically RPC, right? So what do you guys use for RPC? My guess, HTTP JSON. Yes? All right. We could not do HTTP JSON. Why? Performance is crappy. It's terrible, right? We did a bunch of different performance testing. Teleport is very, very sensitive. We're running an online ad auctions. So we have about officially 100 milliseconds to make decisions. In reality, you probably want to be making decisions 10 to 20 milliseconds, right? That requires, and that involves at least 2 to 3 disk accesses, right? Going up to different servers, RPC, getting something from them, coming back, making a decision, going to another server, coming back, right? So roughly, I'd say 20 milliseconds. 99.9th, you might be able to get away with 80 milliseconds. So you need performance. That was one of the biggest challenges going to microservices. How do you get that kind of performance? Turns out in the open source world, there's not much, right? HTTP 1.1, even with pipelining, we're probably getting 1 second tail latencies. Why? Socket connection closed, you wait, you bring up a new socket connection, finally your request goes through. It was terrible, right? JSON, serialization, deserialization performance, not good, right? You're spending a ton of CPU just reading those strings, marshalling, unmarshalling them, all right? So Finagle is another, of course, Twitter open source project, which gives you a bunch of things on top of the performance. First of all, obviously, you get the request pipelining, you get true multiplexing, and you can get basically millisecond level latencies at tails, right? So we were pretty impressed. This is the closest thing to Stubby, if anybody's worked at Google, that you can get in the open source world. It's not as good as Stubby. Nothing is as good as Stubby, but it's pretty damn close. But you get a lot more than that, right? So yeah, sure, you get performance. But let's go back to the things we cared about earlier, right? How does this help tourism? Right? Obviously, this helps the marginal cost. Like if you tell everybody, use one technology, this is your RPC technology, you have no choice, marginal cost is 0, nobody has to think about how do I make a call to another server. There's one standard, super simple, right? But this actually helps with tourism as well. Why? Well, because once you have a single RPC system, you can do things like request ID propagation. What does request ID propagation give you? Gives you awesome gadgets, makes you feel like Bond. So again, for Googlers, you go, yeah, I'm used to this. But if you've never been at Google, what is this? This is Zipkin, which is a tool on top of Finagle, which basically what happens is as your request is jumping through various servers, a single request ID is being passed around with every single request. And you can log that. So you can log who you talked to, what the latencies were, and inside the server itself, you can actually do what's tracing, right? You can say, this is what I'm doing, this is what I'm doing, this is what I'm doing, this is how long it's taking, right? So somebody completely unfamiliar to the system, right, Bond-like, can jump in and within like 20 minutes of digging around, clicking on some of this stuff, go, okay, I kind of understand how all the requests flow. I think I can go and make some proposals on changes, or like, hey, this is really slow. Maybe we should make this an optional call instead of a required call, right? Instead of having to go talk to any engineer downstream, you can figure it out, call them up and say, hey, I've got a CL for you, which is going to improve this problem. So awesome gadgets on top of Finagle. How much time do we have? So, of course, Finagle is not Finagle without Thrift, or in particular, Thrift Mux. So I mentioned there's JSON, serialization, deserialization, right? Personally, my opinion, JSON inside of organizations, bad idea, right? And it's not even the performance, because most companies are not that performance sensitive. It's fine, you'll live, right? For us, actually, it didn't work because of performance reasons. But there's another reason, which is poor discoverability. How do I know what your server actually speaks? Are you going to document every single parameter in your JSON protocol? Are you writing it down? Right? Do you have a schema I can go look at? So you have other tools, right, that you have to use on top of JSON in order to help you that. It's just built into Thrift, right? No additional, right? It's just, that's part of Thrift. You define your schema first. First, you have the discoverability. And everything else comes after that, right? So that's why I'm personally a Thrift fan. There's the performance side, and then, of course, there's the logical API changes. You cannot break the API as long as you follow some rules, right? Never rename fields. Always add a new version number as you add a new field. Basically, you can't go wrong, right? It's pretty hard. You have to be pretty stupid to do something that will actually break your server. The only exception to that, by the way, is Java enums. Thrift and Java enums don't play very nice, so be careful if you do that. Yeah, and Thrift Mux is what I mentioned earlier about Finagle. If you have Thrift Mux, you get basically the millisecond tail latencies. That's the multiplexing of Thrift over TCP connections. So that is those are sort of the two, Aurora and Thrift and Finagle were sort of the things we started with because that was what actually got us the performance we needed to even be able to move to microservices. That took us about 3 or 4 months of experimentation, playing around. Right? When we switched to microservices, the first thing we realized is we were losing money because we were so slow. So we're like, all right, we have to back off. We have to understand, like, can we actually do this in a way that doesn't lose us money? And these were the only technologies we found which could do it. So once we have all that, we go, all right, well, what can we do on top of that? What can we do that's more interesting, that's more powerful? So as I mentioned earlier, every teleport server is an HTTP server. Why? So that every teleport server can have an admin interface. With your admin interface, that's the gateway to everything that the server is doing. This requires no thinking as part of engineer. Right? You click through your little Aurora UI I showed you earlier. There's literally a link there to /admin. You click on /admin, and you see how the server belongs. I don't even know what server this is. Doesn't really matter. Right? I can show up, and I know that I'm going to have downstream clients available. I'm going to have the performance. I'll probably have some basic JVM metrics, and I'll have a bunch of other stuff. And we encourage our developers to add more to this on a regular basis. Right? Make your server different from other people's servers. Right? But make it so it's easily discoverable. You can just click in and see how things work. This is like our standard admin interface here. So one of the first things we built was something I missed very much from the Google world, which is /RPC. Right? So in a distributed system, your server is talking to other servers. Well, which one is it talking to? Should be a pretty simple question, right? Like I should be able to just go to a page which tells me every single downstream system I'm talking to, right? Can you guys do that? Can every single new service you bring up just do that without any additional work by any engineer anywhere? Seems like that would be nice, right? So here's an example of our RPC page, right? What does this do? Well, this only works because we're on Finagle everywhere, right? We didn't have to think about it. We're just like, well, of course, everybody's using Finagle. Everybody's using Finagle. We just have to have a Finagle hook. What do we get? Random server, you just pick it up and you go, oh, well, here are my things, all my clients. Here are all the things I'm talking to. Slipstream, which is Kafka. Identity service, which is how we figure out who you actually are and if we should actually bid on you if you're worth any money to us. Scribe, logging, configurator, experiments, memcache, of course, not currently doing anything. Troves, which is our Redis instance, timeline service, right? And you can do some more magic. So remember, tourism. We want people just moving around through the system like they're Bond. All right, you click on one of these names, and boom, you're going to get every single downstream server that you're talking to. Again, if you're a Googler, you've seen this before, you're like, yeah, of course. But this doesn't exist outside of Google. Right? Nobody does this. Even Twitter doesn't do this, actually. We're trying to get this into the Finagle code base, so it's just for free for anybody using Finagle and Twitter server. So here you can see every single downstream service, what your performance is, your 99th latencies, etc. Anybody want to guess what happens if you click on one of those EC2 links? What's the logical thing to happen? Yeah, you hit the admin interface of that server. Right? So suddenly, like Bond, you're jumping through your system from server to server. You can find performance bottlenecks very, very quickly. Right? It doesn't require digging through logs. Doesn't require like figuring out how somebody else is doing something. It's all basically identical. That's RPC. This is one of my favorite ones, actually, health. Anybody know what sort of health is in a distributed system? How would you define health of your server?
Ability to serve requests.
Right, ability to serve requests. Now, this seems pretty damn simple. It's like, how complicated can health be? I think I've seen more outages because of health than anything else. Hence, it's one of my favorites, right? So here, I mean, health at the basic level is just an HTTP, 200, I'm okay, versus basically anything else, I'm not, right? How does health propagate through the system? Well, it's a very simple concept, but if you use it, you can do a lot of cool stuff. For example, as you're rolling out a new server, if it becomes unhealthy, right? If any of your instances are unhealthy as you're rolling it out, you just cancel the rollout, rollback, okay? Tooling supports it naturally. That's something that Aurora actually has built in. You don't have to do anything additional. All you have to do is expose a okay or not okay, and your server will automatically roll back if it's unhealthy. But health is actually kind of complicated. So here's a question for you guys. Your downstream services are unhealthy. What should you report?
It depends if you require the data online to be healthy, actually. So, and in one case, if you do require a database, you should not be healthy, right? But in other cases, when you have something that's optional for your call, you're still healthy.
Okay, well, let's say a downstream required service is unhealthy or is completely missing.
Then you're not. Okay.
Then you should report unhealthy, correct? All right. You just created a site-wide outage. Why? Or put it differently, there is a site-wide outage. You just made it a hell of a lot worse.
Okay. I don't know how to answer to that, but why did I create the outage?
by choosing to make your service health dependent on the downstream services, what happens? Propagation, right? Imagine this. Your database goes down. Maybe it's a routine maintenance, whatever, for 10 minutes. Your system realizes the database is down. Suddenly it says, I'm unhealthy. So systems around you go, oh, you're unhealthy. I better kill you, right? Maybe bring you up again because something went wrong, right? Starts killing your tasks. The guys above you, of course, they made the same decision you made. They're like, well, my stuff is unhealthy, then I'm unhealthy. They start killing. Not that I've ever seen this actually happen. I mean, this was one of the really interesting things to see going from Google to a small organization like Telepart is nobody had ever thought about this, right? And the obvious answer is, well, if my downstream stuff is unhealthy, then I'm unhealthy. Of course. That's the obvious answer. Yeah.
Actually, we mostly do not have two states. We have some form of a middle state. That,
Yes.
Requires when, for example, when you use some load balancers, they tend to use in-between state.
Yes.
I don't know, closing, maintaining something similar, which is not okay, but it's not okay.
Yeah. So the in-between state is super important. Of hey, I'm up. I did my best to come up healthy, but I think I'm fine. Like everything with me is fine, but I can't actually serve requests because something else is wrong, right? But you have to come up because if you don't, you end up propagating your failure across the entire stack. And one thing that goes wrong can actually blow away your entire data center. Like all your tasks disappear. Because all start being marked as unhealthy. They start getting restarted. They start getting moved around, right? Machines might get automatically shut down because if you have too many restarted tasks in a single machine, maybe you would be thought it was really smart to take that machine offline because something is obviously wrong with that machine. So maybe your whole data center went poof, right? Because suddenly Mesos thinks that, or Aurora thinks that your entire data center, all your machines are bad, right? You end up having distributed failures. So it feels very simple. Normally is very simple. But if you make a few bad decisions and you don't train people to think about it correctly, you end up with very dangerous situations here. So that was one of my favorites. /load. This is, again, a pretty simple concept that we've recently rolled out, but of course ends up being very, very powerful, as frequently simple concepts are. So in a distributed microservice system, you have unpredictable clients, right? And then send you load whenever they want. Usually they forget to ask you for some reason, right? You notice that? They always forget to ask before they send you the 2x load or the 4x load that they were planning on sending, right? So you need two things. You need to be able to gracefully degrade, and you need to be able to auto-scale, right? Bring up more tasks to handle with the load, right? So one very simple system. We expose one number by task, right? Anybody guess what this number is? Let's see how logical this number actually is. What does this mean? Perhaps microprocessor load. But conceptually, what does 0.81 mean here? 80% of capacity. Exactly. You don't have to think about it, right? And we argued about this number for an hour because people were like, well, I want to put the raw number of QPS in there, right? Or I want to put in the raw number of whatever my limiting factor is, and then I want another configuration file which tells me, when. Well, let's make it simple. Let's make it for some random person who's never actually looked at the service to look at it and go, 80%? All right, that's probably okay. I'm definitely not 1.5, right? That would probably be bad. 150% of my load, right? So we went with a very simple number like this, and suddenly our system around it becomes pretty simple too. Your auto-scaling config is a couple of numbers. It says, when I hit 95%, bring up 3 tasks. That's it, right? And you have some completely other system, which you need to know nothing about, which just polls you, looks across all your tasks, takes the average, and auto-scales you. Or if you want to do graceful degradation, we have a simple module you install, and you say, at 100%, just drop load. Right? Well, what's 100%? Well, you can then decide. QPS, my max QPS is 500 QPS per task, right? Or this much CPU. Or if I max out my CPU, start dropping. Very simple concept, though, and you can build tooling around it, which will do a lot of really neat things. Flags. Pretty simple. Separation of configuration and code. Surprisingly, doesn't seem to happen as often as it should. Right? Your configuration should not live with your code, should not be deployed with your code. It should be separate, and you should be able to have a binary that you run under different configuration formats. Why? Because you can't predict where people are going to run it. Right? You can't control, again, if you want tourism, you can't control how people are going to try to do with your code. So give them every single knob they can, right? Let them go to town with it. Provide some obvious defaults, right? So here you'll see a bunch of defaults. But let them change anything they want. I think the most complex system I worked on, search infrastructure at Google, was probably in the tens of thousands, possibly hundreds of thousands of flags they had. It was pretty ridiculous. But almost every single one of them had a purpose and could be used. All right, we're getting near the end here, so let me finish up real quick. And last but not least, Librato, or monitoring. So every single service we bring up, since we've standardized so much of the stuff, we've standardized RPC, we've standardized the admin interface and the incoming thrift requests, we've standardized how it gets deployed through Aurora, we've standardized the packaging system, we use Docker, right? We've standardized so much of the stuff, we're like, wait, for some random service, we have no idea what it does, we actually just build a dashboard for free. Right? What are we going to put on there? Well, we're going to put on maybe thrift requests, maybe latencies. We can throw in tail latencies. We can throw in number of bytes. We can throw in HTTP. You can see this server doesn't do HTTP. It just does thrift, right? And this is completely free, right? And we actually have a link from the UI. So you bring up your service, you can click the link, and you immediately have a dashboard for your service. It's not personalized, but it's actually already useful right out of the box, right? If you want to do more, fine, go do more, right? But you don't have to do anything if you don't want to. You get it for free. So this is the amazing gadgets that you get. So we're almost out of time. Let's see if I can get this working here. All right, so this is my attempt to sort of draw just a subset of all the different things you need to build in order to have microservices actually useful, right? In order to feel Bond-like. And we'll zoom in here real quick. Right, I'll share this. This is actually on our GitHub page if you want to take a look at it. Right, sort of the different colors of what we build. Red color is what's available in the open source world. Right, there's a lot of things you need to do to make microservices powerful and as easy to use as just a single system. Right, you are not going to build this by yourself. It's impossible. You need to have a team of people, a Q org, which is going off and solving every single one of these pieces. Hopefully with open source software. Hopefully not building everything yourself from scratch. But sometimes you have to. It's not all out there. So we've started solving pieces of this, and that's it. Sorry, it's not switching here. All right, questions? We got, I think, 3 minutes. The question is, how do we autoscale AWS instances? That's a good question. It's not part of Aurora yet. I think it's going to be coming soon. We have an internal demo version. The answer here is your scheduler, right? So Aurora is overall, it's a glorified scheduler, right? It takes a job and it says, what do I have available to me? Mesos tells you you've got 3 CPUs and 4 gigs of RAM here, and gives you all these resource offers. And then your Aurora instance decides which resource offer to pick. Right? It can choose any one it wants. Now, the naive Aurora implementation actually picks a random one. Right? So it takes all your offers, it just takes one and throws it onto that offer. The problem with that is you're having your jobs distributed across all your machines, and so none of your machines are tightly packed. Right? Bin packing is poor, or non-existent, really. So with the Fenzo scheduler, it does it differently. With the Fenzo scheduler, it actually looks at the best place to put it, i.e. where we'll get the tightest packing. As it does that, it also looks at any other machine that's empty and sends out a notification saying, this machine's empty. Right? Then you have a very simple job, which could be either in your private data center, could do something with that machine, like shut it down, or in AWS, we just have a simple hook which takes that notification and sends an AWS API command to shut down the machine.
Does your organization decided to give the same environment for different languages? For example, you only support Scala or Java, or you support multiple environments?
Excellent question. So we've had, this is our weekly tech lead debate, Python versus Java, right? We basically support, as first-class citizens, 3 languages, Scala and Java, really we treat it as one, and Python. At an infrastructure level, we basically support everything because we're just using Docker. So you can package up your stuff however you want and ship it. And on our cluster, we're actually running, right, on the Aurora cluster, we're running Elasticsearch and Kafka and like all these different things, right? And we don't even know what languages they're in. We just throw them in Docker containers and things run for us, right? So we're pretty agnostic. The problem is we want to have this telepart server contract. The contract being there's an admin interface, there's an RPC interface, there's a health interface, right? And so for every additional language we want to build, we'd have to build all of those things so that people have the predictability of I'm going to go to some random server and this stuff will just work. So right now we're restricting ourselves to 2 languages, Python and Java.
How do you solve Black Friday situations with scarcity of resources in the AWS?
Yeah, this is a debate I've also had with Wojtek. So the answer right now is really we've reserved all the instances we need for peak capacity. And so we can kind of avoid the problem with peak capacity. If you look at our actual cost, I would say serving is probably maybe 10 to 20% of our cost. And really the majority of our cost is batch, development, and sort of everything else that's happening, right? The problem right now is we're actually paying for a lot of that with reserved capacity as well. We could be a lot smarter and pay it for with spot instances. There's actually an excellent talk from MesosCon from a company that I think it's called Sailthrough, which built their entire data center, thousands of, or I think hundreds, 500 machines or so off spot instances. And they're basically doing spot instances in different regions with different types of machines. And what they've noticed is that when people buy a whole set of spot instances, they always do one machine in one region. So by distributing this way, you can guarantee your data center is always up, even though people are buying out whole subtypes of machines from under you, right? Their cost then ends up being 10% of the cost of running on reserved instances. So that's something I'm really interested in doing. I think that'd be really cool. It's dangerous though, right? But hey, if it happens once a year and you have an outage for 3 hours, you've probably paid for yourself. If you're us, you're in a different world, right? We can disappear for 3 hours. The only thing we lose is the ability to bid on traffic, right? If you have a front end, you should probably figure out exactly the minimum you need for the front end. Twitter, for example, runs I think 2x capacity in 2 data centers, right? So they always have 50% free, and they can just take a whole DC down and fail over to another data center. Yeah.
How do you deal with testing of dependencies between services, and how do you do testing before deployment?
Yeah, so this is testing of dependencies between services. The answer there is not well. This is not something we've particularly invested in, and we've kind of consciously not invested in it. Why? Well, because again, in our world, bugs just cost us money. There's no poor user experience, right? And we usually can catch the fact that something is costing us money very, very quickly, right? For example, we had a graph recently where our Facebook traffic, suddenly the clicks went to 0 over a period of an hour, right? You'll catch that. You'll roll it back. All right, so you cost yourself $10,000 or something, $100,000. You'll figure, right? You'll live with it. In Google Plus, actually, I think our answer was very, very different because we had a very complex distributed microservice architecture. We probably had 1,000 engineers working on probably hundreds of different, maybe not hundreds, but probably definitely dozens, maybe low 100 different kinds of microservices. And the quality of the site was critical, right? You really want to have a great user experience every single time. So there, the answer was much more complex. Probably too much for me to answer now, but the short version is we had end-to-end integration testing, right, for almost everything. We had in the production environments that we would bring up that would run end-to-end tests. We had daily deploys where the entire stack would all be pushed at, basically at the same time, but was order independent. We had an experiment system where you would push your entire stack. Once everything was pushed and you pushed it a second time, then you were allowed to actually turn on features. Why? Because that guaranteed that your downstream dependency was pushed at least twice, so even if they rolled back, your feature wouldn't break. Right? So we had always an N+1 rollout policy, and we did a lot more. I'm happy to talk to you about that offline. It was very interesting. We haven't done anything like that at Telepart. And I don't know what Twitter does about that stuff yet.
One more question from me. I'm not entirely sure. Here. I'm not entirely sure if I correctly understood what you were trying to say when speaking about preventing cascading failures. Do you say that the silver bullet here is just to ignore the health of the underlying systems when reporting your own health?
Not always, but usually correct, right? So you should have two concepts. Really, it's the am I healthy? And why does your health matter? Well, this is mainly for deploys, right? I'm deploying a new binary, I'm deploying either bad code or more likely you're deploying bad configuration, right? You don't want that deploy to go to your entire cluster before you realize, oh shit, I just broke everything, right? So you want some concept of health, so as you're deploying, if you're pointing at some bad downstream server, it tries a couple of times, it fails, that the whole thing gets rolled back, right? So you definitely need some concept of health for rollouts, right? But you need a different concept of, hey, I managed to connect downstream, but somehow my requests aren't working, right? Well, I'm fine. Like I'm talking to everybody I need to talk to, but they're not responding to my requests. I'm okay, right? There's nothing wrong with me. So then you need a different concept, and this is usually, we don't call this health, we call it, well, it's still kind of called health. It's at the RPC layer, right? At the RPC layer, when somebody sends me an RPC, you basically say, hey, I can't serve your request, right? I'm up, I'm around, but I actually can't answer your question. You can throw that just as a server error, which is sort of the easiest way to do it, and then your whole stack just, server errors start spiking, which is fine, but nothing gets killed.